Great. Welcome, everyone. This is Open Source Kubernetes, SIG Instrumentation. Today is January the 16th, and we have some items on the agenda. Don't think Marek is yet on the call, so maybe we can just move straight to Sriram.
Yeah, hey folks. So I had opened a PR sometime last year, which is to add a new metric to see how many times the rate limiter has been hit in client Go. And in the PR, I got a comment that there is already another metric which can be used for the same purpose. And I checked, I compared the metric that I added with the one that is already there, and it seems that they have the same value. And the first question is like, if this is redundant, then we don't need to add a new metric, right? If that's the case, I can close the PR. And while I was working on this, I realized that there were a few missing tests for the client Go metric. So I opened a different PR, adding those tests.
While working on this PR, did you find instrumentation for this existing metric, or is this being instrumented in some other place, so there is missing instrumentation for that?
I am not sure about that.
Okay. Maybe we can follow up on that. Basically, in the code where you were trying to record the metric, are in the same place, are we recording the existing one? Is it this one? Oh, that's a latency. Just wondering if you did not see the existing metric in the places that you're adding here. And does that mean that there is gaps in the instrumentation for the old metric? Maybe that's something to follow up on.
Right. Yeah, I'll look into that.
Thank you. And then the tests PR is this one, right?
Yep. I saw that we have a bunch of metrics, but then I realized that we only have tests for the counter metrics and not the gauge ones. So I just added the tests which are missing for other counter metrics.
Awesome. Yeah, this is something that we had been discussing, I think, in the last SIG meetings also, that I think through you we discovered that there is gaps in our
Yep.
tests coverage. So thank you so much for also contributing this PR to increase that coverage for metrics.
Happy to help.
I can. Oh, there's already approval labels here. So what is waiting for?
I think it needs an approver
Yeah.
from SIG Instrumentation.
I'll assign this to myself in case there is no one else who's interested in reviewing it. And then I will also.
Yep, that's all my items.
I see. Any other comments here?
No, thank you for adding tests. It's very helpful.
Already assigned. Okay.
So, thanks, folks.
Thank you, Sriram. The next one is by me. I just wanted to share this issue that Marek had created. And this is also overlapping with some of the conversations that we have been having recently about trying to push the existing alpha metrics to beta, since they have been in alpha for quite a while, and have some sort of a policy for metrics graduation. That policy is not yet in place. We have just opened up a GitHub issue. I think it needs further conversations, especially with SIG architecture, regarding how we want to proceed with that. But Marek has prepared this list of important alpha metrics that we know that we have been consuming, at least in downstream Google. And so we wanted to get consensus from the community regarding their thoughts on if these metrics are good to be pushed to beta. We are already using these metrics extensively for our monitoring within Google, so it would be nice to reflect that also upstream. I think there is a bunch of PRs that folks have opened up here. This is also a good first issue for people who are just starting out contributing to SIG Instrumentation or Kubernetes open source. Work here would be to reach out to the metric owners, get agreement from them that it's fine to like graduate these metrics to beta, and then there's a few scripts that we have which will update the list of stable metrics. And then maybe a few tweaks will be needed for the tests, corresponding tests for these metrics. If anyone has any thoughts about any of these metrics, now or later, anytime is fine.
No, I think we'll need. Did we already talk about trying to sort those by SIG somehow, or like?
I don't think so.
Like it might be. We somehow need to connect the metrics with the current owners. I think. Otherwise, we'll like if new contributors start to work on it and just try and bump it, then we'll need to. They'll need to then go ask the current owners if they think it should be bumped. You know, like stuff like that.
Yeah. Maybe that's something that we could do is categorize these based on SIGs. That's a good idea. Yeah.
Or we can ask the person who seems interested in helping if they'd like to do that. But we should make sure that people aren't just opening PRs, that we're going and getting reaching out to the owners first.
Yeah. Okay, I can leave a message on the issue. And if anyone here is interested in taking that over, please, you're very welcome to do that. Please express your interest in the issue itself. Oh, that's weird. I just got a Zoom notification that I've been signed out, but hopefully you guys can still hear me from Zoom.
Yeah, I see another SIG Instrumentation host join.
Oh.
Yeah, that's me.
Oh,
Right.
hey, Pranshu.
Yep, right.
Yeah, apparently Zoom doesn't allow multiple sign-ins. It's working right now, so fine. Okay, then we can move on to the last item here. I was thinking if we should just do some tentative 136 planning. I don't know if this release schedule was published or not. At the time when I was adding this note, it was still open. So here, yeah, as you can see, the freeze dates are approaching fast. So we'll have the PRR freeze in 3 weeks. Enhancement freezes in 1 month. So looking at the schedule, I just wanted to maybe start a list for all the features that we would want to pursue for 136 from instrumentation. I only know of these two. The first one is native histograms, which has been coming over and over in conversations. I think recently also, SIG scheduling revived an old thread from last year for they wanted to increase some of the scheduler metrics histogram buckets to capture more granular latency. And we had advised them late last year that we would be working on native histograms soon for that requirement. And we haven't been able to do so. So I was wondering if anyone would have cycles.
I can share an update on that front.
Great.
Well, this is not anything to do with Kubernetes particularly, but so one of the concerns with native histograms was that that they would be exported as native histograms by default when Prometheus scrapes it. And Prometheus, so there was a feature flag in Prometheus called like enable native histograms or something like that. And so the assumption was that when Prometheus made that feature flag stable, that suddenly everyone would start getting native histograms by default. But the Prometheus maintainers changed their mind. And so now native histograms are opt-in at the Prometheus server level, which means that as instrumentation authors, it's actually totally fine for us to enable them in code. And then the collection of them as native histograms instead of as fixed bucket histograms is all configured server side. So I think in that sense, we're unblocked. And it should be a fairly trivial change to how we configure histogram. So they should be able to just do it, and it should just work without any changes to any of our libraries, if that makes sense. So this is done on the histogram options when you create your histogram. So we may need to add some, I suppose, to our histogram options, because we wrap everything, right?
Yeah.
So I think there's 3 parameters related to native histograms, and we should just be able to add those and pass them through. And then the scheduler and anyone else that wants to use them should be able to use them. We may want to come up with some sort of recommendation or some sort of policy, like if you're using non-standard histogram buckets, you should also enable native histograms. And we may even want to start asking people not to use non-standard histogram buckets. So like either use the standard ones if you really want to, or just use native histograms because they're better in most ways.
Was there a hand, Stephen?
Yeah, David, I didn't quite get what you were saying about the feature flag with Prometheus server.
Yeah,
Are you
sure.
saying that we could export native histograms always, and Prometheus, whether it has the flag enabled or not, is able to understand it? So presumably, if on both sides native histograms is enabled, i.e., we export native histograms and the Prometheus server scrapes with the native histograms enabled, that's fine. But if we export native histograms and then the Prometheus server has that flag disabled, is it still able to understand native histograms and effectively store it as a classic histogram? Is that what you were saying?
Yeah, so let me see if I can dig up exactly how this works. But so when you create your histogram, there are 3 options, right? You set them that enables collection of native histogram data in addition to collection of fixed histogram data by the SDK. So enabling it does come with a small memory and like latency hit, right? Because you're recording a little bit more information. Fine, that's how they've chosen to make it work. So that's just going to be something that we have to eat, but I don't think it'll be a huge deal, unless it's like nothing in Kubernetes is honestly that latency sensitive. So, okay, now you've got it in memory. So the next piece, is then how is it scraped? So the only way to get native histograms today is to scrape them using the Prometheus protobuf format. In the Prometheus protobuf format, it contains representation. It contains both the fixed bucket histogram and the native buckets in a single data structure. So there's a histogram type, and that has the static buckets from the SDK and the exponential buckets. So what's exported is actually both of them. Then when it gets to the Prometheus server, now there are new configuration options, letting you keep both, I think, or keep one or keep the other.
Okay, so you export in both formats, and then the server just accepts whatever it can.
Whatever it's configured to. And the default is to only keep the fixed bucket one. So the default hasn't changed.
Is this only for the protobuf?
It's a good question. So we're discussing right now how that's going to work in a text format. So I think there's a Prometheus proposal. Let me find it.
Okay, thanks for walking me through that.
Yeah, so let me just document some of the things.
I also remember discussing some similar points with Damien last year, and
Yes.
his proposal was that we should still gate this, like behind component binary flags.
So that was the plan if Prometheus was going to turn these on by default someday, because then it becomes dangerous for us to add new native histograms, because suddenly someone's just going to get a native histogram that wasn't expecting it and hadn't opted into it in any way. So let me just add some links. So in the Prometheus scrape config, there is now an opt-in scrape native histograms. Too many tabs. And then there's also scrape histograms. Okay. But the idea is that you can and there's a nice big explanation if you search for always scrape classic histograms on the Prometheus docs, basically giving you a way to migrate. So now that the migration story is much easier and the compatibility story between the two is much easier, I think we should just for any histogram where we want high levels of detail, we should be enabling the native histogram options in the Prometheus Go client. So this is on the Prometheus server side, but it should be, yeah, good, you found it. So there's in other words, there's a lot of control that users have over which version of the histogram they get. And so the only consideration for us as instrumentation authors in Cube should be, do we want to pay the memory overhead cost to add this as something that we're collecting, right? And so I think the answer is going to be yes for any histograms where we're already using a large number of buckets or want this feature.
Okay, that makes sense. Thanks.
For the memory concerns, will we need some sort of benchmark testing?
There are benchmarks in the Prometheus Go client library that we can probably just run and then paste somewhere. I haven't looked at them though. It's native histograms are, in some cases, assuming you have like, I forget how the config works. I think you get to limit your number of native buckets or something as well. So a lot of it will depend on exactly how you've configured them. But it's not significantly more expensive than fixed bucket. The one thing that can happen right with a native histogram is that it can rescale. That typically happens once an hour, where it will downscale and then rescale up a bunch. So it's not in terms of performance, it's not a big difference on the usual case. It may be like a tricky 99th percentile latency might be slightly higher, but it's I don't think it's something that we need to worry about. It should be equivalent to doubling the memory and CPU cost of the histogram at worst case.
And do we want to do this for all histograms at once? Do we want to pick
I
up
would
some?
rather start by allowing people to opt in. Just because native histograms are slightly more expensive.
Yeah.
And they're an excellent replacement for some of our histograms where we have just oodles of buckets, right? So some of the scheduler ones potentially, and some of the API server ones.
Mm-hmm.
And so I think in the first release, at least, I would love to see us turn them on for a few of those key super high bucket count metrics, and then see how people are using them, and whether they're worth whether any issues come up or anything like that. So I think it would be good to collect feedback on some of the ones where we know it's going to be very valuable before we opt in, like very basic histograms, because they are a more expensive representation of histograms. Like they have more buckets. It's compressed, which is nice. But yeah, anyways.
Okay. Looks like good news is that we can safely use them, so we don't need to think through a row migration story. So
Yeah.
thanks.
We should not do a migration.
Okay.
I just want to add, what Damien, I'm not sure if there's any, these changes affect the discussion, but what we talked about earlier was doing a per component kind of thing where there would be CLI. So this is all, what we decided to include in the kit, basically. And there's, people would, what we assume is on a per component level, always create classic histograms would be enabled, and enable feature native histograms would also be enabled. So for a short span of time, I mean, at least until the migration is done, we would be piping out both formats.
So this is all server side config. So this is ours.
Yeah.
If you just turn it on in the client, then each person can migrate on their own schedule with their own server config, right?
Basically, the client will be exposing both the formats. It's up to the server how it's going to scrape, which one it's going to scrape.
Yes. So the client will have all the information in memory. And then when you ask for your metrics, if you, let's say you use the text format, you'll just get the classic histograms because we don't have a text representation of native histograms yet. And if you use the protobuf format and you've turned on one or both of these scrape native histograms or always scrape classic histograms options, then you'll get some native histogram data that way. Does that make sense? Like this is all opt-in from whoever's sending the request to the metrics endpoint.
So we would maintain both representations in memory.
Yes, so that's
the
Prometheus Go client library. When you turn on native histograms, we'll always maintain both.
Yeah.
Of course, if you don't need the classic ones, then you can set your buckets to like one bucket or something, so it's cheap. But
yeah, I think so. Damien actually, he had this idea that we could in the future turn off classic histograms completely once the component has migrated, and just stop on a per component basis, of course. But yeah, this makes sense, I guess.
the only issue with that, and so because Prometheus now offers this always scrape classic histograms option, is that for someone who sets that, when we remove the classic histogram, that'll be breaking for them, right? So it's unlikely we'll ever be able to actually do that and remove the classic histogram. The intention of this is not that this is like summaries and histograms where you're moving from one type to another and we're trying to get everyone off of one boat and into another boat. The idea is that like these are just two representations of the same set of data, and we'll give people choice between the two,
Yeah.
at least for this major version of the Prometheus server.
Maybe.
Yeah, we were hoping to. Sorry, go ahead.
Go ahead. Anshul.
Yeah, so we were essentially hoping to save on space with kind of turning off classic histograms after a while. But yeah, this totally makes sense because Kubernetes will always have, and Kubernetes components specifically will always have classic histograms. Like they will. It's not good to assume that we would, like, all histograms would move to native ones, I guess. So, or is it like, could all histograms move to native histograms? Could they just, leave the scaling dynamic and just, is there a use case where we would need fixed buckets?
Or you would need, say that again?
Is there a use case where anyone would prefer to have classic histograms over native histograms?
I mean, classic history. So it's a similar discussion as like comparing summaries to histograms, right? Where, for example, if you want to calculate the 99th percentile latency, a summary that has the 99th percentile latency on it is better in some ways, right? But histograms are nice because they're more flexible, right? So if you really want to know the number of requests that were less than or equal to 100 milliseconds, then having a bucket that is fixed at less than or equal to 100 milliseconds will give you perfect results in your queries every time. But native histograms is nice because you can pick any number and it has a maximum theoretical error on it, right? So like generally everyone should move to native histograms. They are potentially more expensive, I think, is the other thing. So some of this is like storage cost versus right.
Yeah, because they're doing it on the fly, right? The quantiles.
Yep.
Well, you have more buckets as well, right? There's more classic histograms. People would store like 10 buckets or something by default, and a native histogram might have 30 or 40 buckets, right? And it's supposed to be in this nice compressed format, but it is like more, depending on how you're storing it and how you're querying it, like it might be more expensive. So that's why I think it's definitely better to have a native histogram with 40 buckets than a classic histogram with 40 buckets, which is why I suggested we like start with some metrics that we know are going to be where this will be very useful, and get feedback from people who are using it as to whether it's a good thing, whether we should do it for more metrics. I suspect that once we open the floodgate, that people will start asking for it, and we'll start using it, and we'll get feedback fairly quickly. But
I guess one of the
one of the
questions.
concerns.
Go ahead.
Sorry, just my final note. One of the concerns that I think I'm not familiar with the implementations, but was that if there's a 90, like for example, for the long time there's a fixed even with native histograms there's like this 99 percentile estimation, right? And then something happens that's like it's so far off that it's the new 99 percentile, and the 99 percentile just shifts back a lot, right? So then we have a whole new number of buckets being maintained.
The buckets are stored as deltas. So if the bucket values are 0, then Prometheus isn't actually storing or sending them. So like if there's 10 buckets in a row that are all 0, that compresses out in the way that native histograms are stored. So that is not as big of an issue. The bigger issue is that if you have a maximum number of buckets that you allow, and you get an observation that's way outside your current range, you need to increase the size of buckets by merging them together, right? They're powers of 2s. So that's called that's downscaling, right? And so when you downscale, if you get an observation that's way outside your current range, it means that all the other observations all the other buckets lose detail. So getting an observation that's super far out means that all the rest of your stuff becomes less granular. So, but it's a trade-off, right? Normally, in classic histograms today, that just ends up with like you not being able to see it at all. It ends up in the inf bucket, and then you don't know anything about where it could be, right? So,
I was
they're not
thinking that's
perfect.
like
Yeah,
a good thing in some cases where, we saw it in scheduler where they were trying to add microseconds and even, granular buckets inside microseconds.
Yeah.
And in that range. So that was like a good case to, for fixed buckets where we don't allow that beyond. So I think Damien suggested 18 buckets, but they are reaching 30 right now.
Yeah, they should be using that. So I think we're all in agreement, and I think we're also over time. Is there any, if you have any concerns, I think there's an issue somewhere. We should probably write down what the plan is, and then if you or Damien or anyone has any concerns about the plan, then we can hash those out there and maybe bring them to a future meeting.
Yeah, great. Sounds good. It's encouraging definitely to look at like there is a straightforward path for us to enable this. This is especially an asked for feature, so we excited about that.
Yep. All right.
Okay. Thank you, everyone. See you next time.
Thanks.
Bye-bye.
Thanks for driving this.